Today, I want to just talk with you guys about one of the games that comes up in the problem section in section 2. The game is called Turning Turtles. They mention in the layout of the problem that this game was created by Hendrik Lenstra. Hendrik Lenstra was actually a really great number theorist. I knew him when I was a graduate student, even an undergraduate student, at UC Berkeley, where he was a professor for many years. He was actually a teacher of mine when I took a graduate number theory course. Sometime then, in the late 90s or early 2000s, he left Berkeley and went back to, I believe it was the University of Leiden in the Netherlands, where he was from. But this is one of the things that he did. He created this game called Turning Turtles, and it's very similar to the game of NIM. So let's talk about this game. In this game, you have a horizontal line of coins. You can start with any number of coins, call it N coins. Some coins show heads, some coins show tails. A move in the game consists of turning over one coin from heads to tails. And in addition, if desired, you get to turn over another coin, always to the left of the one you first turned over. And when you say turn it over, it could be from heads to tails or from tails to heads. For example, consider this sequence of 13 coins. In this sequence of 13 coins, you see 5 heads. So in this game, we have 2 players. Players alternate moves. The player who goes first in a position like this could pick any one of these 5 heads and turn it over. For example, a player might turn over the head in position 5. And then that player would have the option of turning over any of these coins from 1 through 4. Then the next player would go, and so on. It would go back and forth. When there are no more heads, there are no more moves, and the game is over. The last player to move, which means to turn over heads, is the winner. How is this game like NIM? Well, the interpretation that makes it like NIM is that we take a position like this and consider the heads to indicate a stack of coins with the position number there as the number of coins. So when you see these 5 heads, we think of a NIM position with piles of size 2, size 3, size 5, size 9, and size 12. Now, in this manner, you'll see that any turning turtles position can be turned into a NIM position. You might think any NIM position could be turned into a turning turtles position in the same manner. But you'll notice that, of course, these heads are all in different locations. So any NIM position that doesn't have any 2 piles of the same size could be thought of as being like a turning turtles position. But here's a quick fact about NIM. In any NIM position, having 2 piles of the same size can effectively be ignored when it comes to strategy, with the knowledge that a play on one of these piles can be mirrored by the next player with a play on the other. So, for example, if you have a NIM situation that looks like 5, 5, 8, 9, 10, so there are 5 piles, 2 of them of size 5. Let me write that a little differently. And 1 each of size 8, 9, and 10. What's really important to play this position right is to understand the 8, 9, and 10. The 5 and the 5, of course, you know when it comes to the NIM sum, 5 plus 5 will always be 0, since any number plus itself is always 0 in the NIM sum. So it doesn't alter the NIM sums if you just think of the 8, 9, and 10. If you're looking for a winning move, for example, this is an N position, there is a proper move to guarantee a win if you're the player who goes next and you play perfectly after that. You really just have to look at the 8, 9, 10 and you can move from that. If another player plays from one of the 5s, you can just mirror the move with the other 5 and then just continue to ignore those, and really the gameplay is with the 8, 9, and 10. So with that knowledge, you can really think of any nim position as being like a turning turtles position, where if there are 2 5s, you can just ignore them. If you have 3 5s, ignore 2 of them and treat it like one pile of 5. If you have 17 5s, you could ignore 16 of them and treat it like one pile of 5. Everything will play exactly the same, except for this mirroring when one stone from a repeated pile is taken. Okay, now let's get back to the turning turtles position. This is the position we were looking at. How do you play turning turtles then? Well, you play it just the way you would play the corresponding nim piles. Let's look at this nim position. This nim position, as we wrote down before, consists of 5 piles, 2, 3, 5, 9, and 12. Writing those in base 2, in order to compute the nim sum, 2 is 1, 0, 3 is 1, 1, 5 is 1, 0, 1, 9 is 1, 0, 0, 1, and 12 is 1, 1, 0, 0. And we take the nim sum, we get a 1 in the ones pile because there are 3 1s there, and we get zeros everywhere else. So the nim sum of all of these numbers is just 1. So this is an end position in nim, so I claim that this is an end position in the turning turtles game. Why does that work? Well, what is the correct nim move? The correct nim move would be to get rid of that 1, which we can do from any of these 3 1s that are in that highest 1 position in that nim sum. There's only 1 1 in the nim sum, so that's easy. It has to be from the 1s column. We can either take 1 away from the 3 pile, 1 away from the 5 pile, or 1 away from the 9 pile. Let's say that we decided to take 1 away from the 9 pile. Change that to 8. That would be a winning move in nim. What would that correspond to in turning turtles? The turning turtles move is to flip the H in position 9 and also flip the T in position 8. When you flip the H to a T in position 9, that's like taking away the 9 pile, and flipping the T in position 8 is like putting back a pile of 8. So flipping the 9 and the 8 corresponds to taking 1 away from the 9. What if instead of that, you wanted to take 1 away from the 3 pile? Because that's also a winning move in nim. Well, taking 1 away from the 3 pile, moving that 3 down to a 2 in nim, is like turning, the turning turtle move would be to flip the H in position 3, and then flip the T in position 2. What happens, and I'll put this up here, if I turn this into a T and flip, I'm sorry, we want to flip the H as well, I should say. Not flip the T, flip the H in position 2, as well as flipping the H in position 3. And we flip the H in position 2, also to a T. Well, that corresponds to eliminating the 3 pile, as well as eliminating the 2 pile. Now we only have left this 5, 9, and 12. We only have left the H in position 5, 9, and 12. So it looks like that corresponds to a nim move of taking away all of the 3 pile and all of the 2 pile together. Whereas the correct nim move was just take 1 from the 3 and make it a 2. But you'll notice that what we have left after the correct nim move has 2 2s, a 5, 9, and 12. And we've already explained that having 2 2s is really functionally equivalent to just ignoring those 2 2s entirely and just looking at the 5, 9, and 12. So here's the idea. Turning turtles position is just like a nim position, with nim piles wherever of the correct value wherever you have an H, the value, the size of the nim pile corresponding to the position of the H. And turning over an H and turning over a coin to the left of it corresponds to either reducing a nim pile, if you turn over an H and turn over a T to the left of it, just reducing the size of one of the nim piles, or if you're turning over an H and an H to the left of it, that's like getting rid of two piles, but really that's like instead replacing, let me start again, that's like removing a stone in nim to make the size of one pile match the size of a smaller pile, and those two can then effectively be ignored. So the play in Turning Turtles is then just like the play in nim. In this particular example, if you turn the H from the position 3 and position 2, you're left with the 3 H's, and then you continue. Everything's identical as far as the nim sums are concerned, and as far as the effective play from there on out. So it's just a really neat game that's nim in disguise.